Good morning everyone. Welcome to the CobBauge Training Day. Join us for a full day of online training where we're going to visit the materials and the processes and also some of the sites of the pilot buildings that are currently in construction and some of the ones that have already been completed. We're going to introduce you to the design process and also the specifications, the construction guides and the tutorial films. There will be a bunch of scientists to meet, engineers, architects, builders, who have all taken part and also led the project. But first, we're going to give you a short idea of the background to the CobBauge project, and then a short video showing you a little bit about the actual building itself. And from then on, we're going to get to the meat of the topic and the day in its detail. Thanks for watching, and I hope you really enjoy it.
Cement has become the go-to material for modern architecture, and cement on its own is responsible for 8% of all CO2 emissions worldwide. There is a vital role for other materials like earthen materials, and that has, apart from being part of the new solution, it has a huge tradition. I think it's a third of the population of the world live in buildings made from earth.
Earth building in construction is one of the oldest forms or oldest methods of construction throughout the world. In Europe in particular and other parts of the world, cob is one form of earth construction. Around about the middle of the last century, when the building regulations came in, it meant that that form of construction was no longer a viable option for contractors. And that's primarily due to the lack of thermal performance, perceived thermal performance. With the CobBauge project, we're looking to sort of hit the building regulations and the thermal aspects head on. So we've developed this material that complies with the current UK and European building regulations for thermal performance. That in itself means it opens up cob construction once again to the contractors that have not been able to use this material.
So with the CobBauge technique, what we do is we take that thermal mass and we use it to hold up the roof, but we also add an outer layer of light earth, which is a great insulator. And light earth just means taking a sticky clay soil and mixing it with some light fibre. So it's a bit like wearing a woolly jumper outside of your skin. You know, it's giving you an extra layer of warmth. And CobBauge, the innovation in CobBauge is to combine those two in the same wall. That's basically what it's about.
I'm going to talk about the materials we've been using to make the wall. Ultimately, we'll be constructing something that looks a lot like this. So on one side we've got the thermal mix, the other side we've got the structural mix. The structural mix is more or less traditional cob, and that's made of local clay, local earth, and that's mixed together to make your normal clay cob with some kind of fibre. Now for the thermal side, we make up a slip, and you see here it's a very clay-rich slip. It's actually made from the same soil as this, so it's the same material, so you can use the structural and the thermal is the same clay soil. And with that we will mix this with something called hemp shiv. Now hemp shiv is the inside part of the hemp stalk, and here is a sample that we made that we've already tested these in our heat flow meter, which tests thermal conductivity. So basically what we're trying to do is we're trying to glue these two materials together.
Now, depending on how much soil you put together, how much fibre you put together, you can get different properties. This is traditional cob, very clay rich, about 2.5% fibre, and this is a structural material. You can get 2 megapascals as compressive strength from it. It will hold up a complete building. And there are evidence of places in Shabam, for instance, in the Yemen, where there are buildings which are 5 5, 6, even 7 stories high, made from something that's not dissimilar from that. So the building that's being put up in France is, in effect, a very small 2-story building. That particular building is a pilot stroke demonstration building, which ticks all the little boxes for people. It also gives us the ability to put sensors in the walls and scientifically prove things like drying out times. So all in all, you could end up with a modular package that was based on subsoil and fibre, which is an extraordinary thought.
The amazing thing about earth is it's infinitely recyclable. When I go in to repair a cob building, I literally take the old wall and stick it in a bath and re-soak it. And that piece of wall can go on forever. And honestly, what else is like? I mean, I don't know of anything else except stone that you can just keep using again and again.
There's a romantic notion that perhaps you buy the land, you plant the land with the hemp or whatever fibrous material you're going to use. You then mix the two together to form your wall materials. So the localization of that wall construction in its entirety could come from the land on which you build your building. So the embodied energy that goes into building a CobBauge building can be quite minimal. The carbon footprint of constructing out of cob construction or CobBauge construction will be far less than what would go into a concrete building or a building using more modern man-made materials. And I think that's certainly going to be attractive for a future generation, a generation that seems to be coming forwards and has a greater awareness of the sort of greener issues and sustainability.
We are standing here in the CobBauge building, which is built from subsoil and agricultural grade fibre, both tending to be waste products which have been turned into a very energy efficient building. This reduces the overall low carbon content of the building itself through its structure, but also what it does do is it reduces the overall amount of energy which is actually used to heat the building. All these aspects are coming together to provide confidence by the contractors, the general public, engineers, designers, to be able to build using this technique. This is located in a city centre campus, right at the heart of a research-led university. The University of Plymouth has been supporting impactful research in the area of sustainability right across the campus. Aspects such as living walls, and these have been proving that you can save as much as 1/3 of the energy of a building by actually installing a green wall onto its exterior. The university has supported this particular project, the CobBauge project, right from the start. The climate crisis is now. The energy that's saved within buildings like this are going to contribute huge amounts to be able to reduce our overall carbon footprint. They are needed.
I'm Tom Morton. I'm one of the Bucky team, and I will talk you through today's event. We've got a great day planned. There's a morning session where we're going to look at the science of cob and then the building process. And then in the afternoon, we'll look at the process of designing cob. And in between, we'll be touring the three pilot building sites in Normandy, in Plymouth, and in Norfolk. The other thing we will do through the day is show you some of the online resources that we've prepared for the project. So this is the CobBauge website, which is available in English and French versions, www.cobauge.eu. And within that, within the resources section, there's technical documentation. And most of the resources that we're going to show you today, training tools of the design guide, the details, the specification, and indeed the training videos can all be found on the website, which you can look at after today's event. But we'll show you those resources today and talk you through some of that information. So the CobBauge team has a very wide range of partners, including architects, engineers, builders, material scientists, and others from the University of Plymouth and Caen, the Parc Naturel Régional des Marais du Cotentin, Bessin, Hudson Architects, and Earth Building UK and Ireland. And all of them have been brought together under the European Union's Interreg programme. You'll meet most of the participants in the project today at various stages through the event.